All right, we're going to reduce a radical, okay? So let's start with the square root of 18. Okay, now what I want to do in this video is I want to kind of talk to you about ways we can look at this, and I want you to see the simple arithmetic that's involved in what we're doing. So we know that this radical symbol, as fancy as it looks, all it's telling us is that we're looking for the square root of 18, meaning some value n taken to the square, in other words, multiplied by itself, right? It's going to be equal to 18. That's all it's telling us. That's it. As fancy as this thing looks, that's all it's telling us. So we assume the index, right? The index is a 2, right? If there's nothing written there. Okay, that's the first thing we want to take into consideration. Now let's talk about something else. So it's a square root, so we know it's something times itself is going to give us 18. That's going to be the answer, right? That's going to be the square root of 18. So let's think about some things. Let's think about some integers that multiply against themselves that we can square that can get close to 18. Right away, we should probably be coming up with 4. 4 times 4 is 16, so 4 squared is 16. Well, the next integer from 4 is 5. 5 squared, or 5 times 5, is 25. So it's somewhere between, on the number line, between 4 and 5. Now, we know that 4 squared, right? 4 squared is equal to 16. We know that 5 squared is equal to 25. Whoops, 5 squared is equal to 25. So we know that, right? What we're after is, I'm going to change colors here. What we're after is 18, though. Something squared to give us 18. Now, we know it's going to be less than 5, more than 4, right? Greater than 4. But we also can kind of discern something else. We're after a number, a value, I should say, that is going to be closer to 16 than 25, right? So it's going to be closer to 4 squared than 5 squared. So it's going to be 4 point something, but it's going to be less than 4.5, right? Because if 18 were closer to 25, that means it was getting closer towards 5 squared than 4 squared. Because even if it's 4.8 squared, right, even though we see that 4 in the whole number spot, it's actually closer to 5, right? So it's getting closer towards 5 squared. But we see 18, and this is just how to think about it. We're not going to go through all this each time. I just want you to kind of understand how to think about these radicals. It makes them so much less intimidating if we understand them. So 18 is closer to 16, right? So we know it's going to be closer to 4, which means it'll be 4 point something less than 5. So 4.2, 4.3, 4.4, but not 4.5 or greater, right? So that gives us an idea of what we're shooting for. So now the next step is going to be, let's try and think about how we can factor this out to break it down and simplify it. Okay, we can factor 18 out. We could go 6 and 3, 9 and 2. Let's go 9 and 2. 9 times 2, right? So the square root of 9 times 2 is the same as the square root of 18, because 9 times 2 equals 18, right? So is there anything else we can factor out? We can't really factor out the 2 evenly, but we can factor out the 9, because that could be 3 times 3, right? So another way to write 3 times 3, we could write 3 squared. So we'll move on down the line. And again, you wouldn't need to write, I'll circle it, you wouldn't need to write all this here, right? This is just a visual aid to help you guys kind of track the flow of consciousness here. So we're going to go into the next bit, 3 squared. We still have that multiplied by 2 right here, right? Because the 3 squared is just accounting for this 9. So multiplied by 2, right? Now what do we know about this radical? Remember, the index is what? A 2, isn't it? When we don't write an index there, it's assumed to be a 2. So it's the square root. Well, this is 3 squared, right? So what's the square root of 3 squared is 3, right? So we're going to bring that 3 out. Now we have 3 times the square root of 2. Okay. All right, so this is where we're at now in terms of simplifying this original radical. Right, and I'm going to write this a little cleaner for you. All right, so let's kind of track. Let's kind of track back through this thing here. So we started with the square root of 18. We talked about that and how to look at that, right? Then we moved down to, we reduced it down to square root of 9 times 2. And we factored out the 9 to 3 squared, right? And now we're at 3 times the square root of 2, right? And this could be our final answer. We could say, okay, we've reduced this all the way. But now let's kind of take it out a little further. If you have a calculator handy, you can go ahead and grab the square root of 2, and you will find that the square root of 2, go ahead and carry it out, square root of 2 is equal to 1.41, I believe. It's a bit longer than that, but we basically get 1.41. And then if we multiply that by 3, because it says times 3, right? It's the square root of 2 multiplied by 3. Well, the square root of 2 was 1.41, so we're going to multiply that by 3, and that will give us 4.24, I think. And then if we take 4, so now we're at 4.24, right? Which is what we were talking about back here. We were saying we knew it was going to be closer to 4 than to 5, right? It was going to be on this side of those decimals. It was going to be 4.2, 4.3, 4.4, but not 4.5 or greater. And we were right on. It was 4.24. Now, let's see. Is the square root, because remember this is a square root, here's our index right here, right? Index to the radical or order to the radical. So 4.24 squared, if we hit that in our calculator, we're going to go ahead and get 18, which brings us right back to the radicand. All right? So that's a way that we can reduce the radical down. That's just one example. We'll do a few more, and I'll put up, I don't know, 10 or 20 more that you can just follow along with. And I'll try and make each one a little more diverse than the last one, or a little more complicated, or just a little bit different, so you see the different kinds of problems that you can face on an exam or something like that. All right, cheers.